So this is 2.4. We're going to be dividing polynomials. There's two different ways we can divide. We have long division, synthetic division. First thing we're going to do is long division. When we get to synthetic division, you'll see synthetic is a lot easier than long division, but there will be a question on the test that says divide using long division. So you have to know how to do this. So the big polynomial goes inside. We have 6x cubed minus 19x squared plus 16x minus 4. And then the little binomial goes outside, x minus 2. Yeah, we do. All right, so you guys all did this in Algebra 2 last year. We ask ourselves, what times x gives us 6x cubed? Or you can divide. 6x cubed divided by x would leave us with what? 6x squared. We put it at the top. So then, whatever we put on the top, we multiply it with what's outside. So 6x squared times x would be 6x cubed. 6x squared times negative 2 would be negative 12x squared. Then we change the signs here. Change a sign, and add them together. So 6x cubed minus 6x cubed cancels. That'll always cancel out. That's your goal, is to cancel, and then go to the next term. Negative 19x squared plus 12x squared would be negative 7x squared. Now we do the same thing. What times x gives us negative 7x squared? Or we divide negative 7x squared by x. So that would be what, Gia? What? Say it again. Negative 7x. Just x. Negative. Just x. Then we multiply what's on top with what's out front. So negative 7 times x would be negative 7x squared. And then plus 14x. What do we do next? Change the sign. So this becomes positive. This one becomes negative. And add them together. So negative 7x squared plus 7x squared cancels. That's our goal, is to cancel it out. And then we bring down the 16x, combine it with that negative 14x, and we have 2x. So if we divide 2x by x, that leaves us with 2. So we put the 2 on top. Then we multiply what's up top with what's out front. So this would be 2x minus 4. What do I do next? Change the signs. This becomes negative. This becomes positive. This cancels out. Negative 4 plus 4 is 0. My answer is this thing up top here. Yep, there's no remainder, so this is just my answer. If you notice, it helps with these to be organized. Our x cubes are on top of each other. Our x squareds are all on top of each other. Our x's are all on top of each other, and then our constants. So everything's going to be in the same degree in that column. So it helps to be organized. That way you know what you're writing up top, what needs to go in that.
You said we're going to have a long division one?
Yeah, you will have a long division one on the test. Yeah. As we look at the next slides, it's going to say if we divide by a binomial, so our divisor, what goes into it, if it goes in evenly, meaning we have a remainder of 0, that is a factor of our polynomial. So x minus 2 is one of our factors. When we divide it, we're left with this smaller one here, so we can find another factor just by factoring it, because we know how to factor quadratics. If it's an x squared, we can factor that easily. How do I factor this? Multiply 6 and 2, so that would be 12. What are two factors of 12 that add to negative 7? Negative 3 and negative 4, so I have x minus 3 and x minus 4 what do I have to do next? Divide them by 6. Since I multiplied by 6 in the beginning, I need to divide both of these by 6. Simplify if you can. Whatever doesn't simplify moves to the front. So I can simplify this to 1/2, but the denominator has to go in front of the x. So this would be 2x minus 1. I can simplify the next one to 2/3.
Do you have to do this now?
And then this would be 3x minus 2. And then our other factor that we started out with was x minus 2. So our polynomial up at the top factors into these 3 binomials. So these are all of our factors of this original equation up at the top. All right, this slide just says that the degree of the divisor has to be less than or equal to the degree of the dividend. So like what we just did in the last one, what was on the inside was x cubed, what was on the outside was x minus 2. So the degree of the outside has to be less than what you're dividing it into on the inside. If the remainder is 0, then it divides into it evenly. Yeah, we'll see. I think the next. So next we're going to look at synthetic division. So again, you guys did this last year, so this should kind of just be a review. When you move vertically, you add the terms together. So up and down, you're adding these on the inside of the box. When you move diagonally, you multiply by the number on the outside. So you're multiplying the outside of the box. Synthetic division only works for divisors of the form x minus k. If you had like an x squared minus k and it asks you to divide that, synthetic division wouldn't work. So it only works when it's like x minus or x plus some number. And then here, yeah, synthetic is definitely faster. Here it just shows us that if we had a factor, let's say our factor of our polynomial was x plus 2, what would x be equal to? Negative 2. So you change the sign when you put it into your synthetic division. So that number that goes on the outside, you change the sign when it's written as a factor like this. If it was written as x is equal to something, you don't change the sign. So we'll do a couple examples of those. So the next page. It says use synthetic division to divide. So we're dividing x to the 4th power minus 10x squared minus 2x plus 4. So what's the number on the outside going to be? Negative 3. So you always have to change that number that goes on the outside. Inside the box, we put all of our coefficients of our polynomial. But we have to make sure that all of our degrees, so if we start with x to the 4th term, we need everything after that to be represented. Awesome. So here we're missing an x cubed, so I have to add in a 0x cubed in there. So when I list my coefficients, I need to make sure that 0 is in that x cubed spot.
Wait, why are you adding a 0x?
Because I need all of my degrees. If I start with 4, I need to have x to the 4th power, x cubed, x squared, x to the, just x, and then a constant. So you have to have all of them represented after the one that you start with.
Oh, okay.
So you have 1 plus 0 minus 10 minus 2 plus 2.
Awesome. So I would have 1, 0, negative 10, negative 2, and 4. So this just came from my coefficients in my polynomial here. What do I do when I start synthetic division? Anybody remember? Bring the first one down. And then on the outside you multiply, so this would be negative 3. Add on the inside, so negative 3. Multiply to get 9. Add negative 1. Multiply 3. Add positive 1. Multiply negative 3. Add 1. Now what I just found are the coefficients to my answer. if I started with x to the 4th power and I divided by just an x, my answer is going to start with x to the cubed power. So it's, or x to the 3rd power. It's just 1 degree less than that. So this will be 1x cubed minus 3x squared minus 1x plus 1. And the last number is your remainder. So my answer would be x cubed minus 3x squared minus x plus 1, remainder 1. Another way we can write our remainder is as a fraction. So x cubed minus 3x squared minus x plus 1. We can write our remainder just by adding the remainder, which was 1, over what we just divided into it, so x plus 3. So these are just two different ways of writing the remainder. You can write remainder 1, you can write 1 over x plus 3. I think writing remainder 1 is easier, but I'm showing you the second way also because on an SAT, they'll probably leave the remainder as a fraction. So it's good to know that that's just another way of writing the remainder. You just write it, whatever number you found as your remainder, over what you divided into it. All right, so next we have the remainder and factor theorems. First, we're going to look at the remainder theorem. It says the remainder obtained in synthetic division process has an important interpretation as described in the remainder theorem. So the remainder theorem tells you that synthetic division can be used to evaluate a polynomial function. That is, to evaluate a polynomial f of x when x is equal to k. You divide by x minus k, and the remainder will be that f of k. So if it tells us to evaluate some polynomial, we can take that number and use synthetic division instead of plugging it in. So I'll show you the next example. It'll make more sense when we actually have an example to look at. So for here, it says use the remainder theorem to evaluate. We're not being asked to divide here, but we just evaluate. So I could take negative 2 and plug it into all of my x's and find what f of negative 2 is. Or I could use synthetic division and find whatever my remainder is. That would be the answer I would get as if I had just plugged it in. So what number goes on the outside of my box? Negative 2. Here you don't change the sign because it says x is equal to negative 2. What coefficients go inside my box?
3 plus 8 plus 5 minus
So 3, 8, 5, and negative 7. Always double check. Am I missing any degrees up here? I have cubed, squared, 1, and none. So I'm good. So let's go ahead. Drop the 3. Multiply. Add. Multiply. Add. Multiply. Add. So what's my remainder here? Negative 9. So f of 2, when I plug, f of negative 2, when I plug in negative 2 into my polynomial, I am going to get negative 9. So if I were to just plug in negative 2 here, I have 3 times negative 2 cubed plus 8 times negative 2 squared plus 5 times negative 2 minus 7. If I evaluate this, I'm going to get negative 9. What's negative 2 cubed? Negative 8 times 3? Negative 24. And then 2 squared is 4. 4 times 8? 32. Negative 2 times 5? Negative 10 minus 7. Negative 24 plus 32 is 8 minus 10 minus 7. So this would be negative 2 minus 7, which is negative 9. Got the same answer. So f of negative 2, when I plugged in negative 2, I got negative 9.
Let me ask you a question. If you were to write,
So if this question asked us to divide, our answer would be this part here. Oops, this part. Those would be the coefficients of our answer. So since we started with x cubed, this would be 3x squared, so 1 less, plus 2x plus 1, remainder negative 9.
can you write it
As a fraction?
Yeah.
3x squared plus 2x plus 1 minus 9 over x plus 2. I'm just showing you if this question were to ask you to divide, this would be your answer, because that's what you get when you divide using synthetic division. This one just asks you to evaluate here. So we just plugged in -9, so that would be our answer. F of 2 is equal to -9.
Wait, Ms. Carver, why is it x plus 2 again?
Because x is equal to -2, so this, like factored, would be x plus 2.
Is the remainder always going to like give you the same? Like if you were to plug in the remainder, it would always give you the remainder? So like do you always have to check?
No, you don't always have to check. So like the stuff in blue, you don't have to do that to check. If you wanted to, you can. But synthetic division is supposed to be an easier way of evaluating other than just like plugging it in. So if you had like really big numbers, I don't know, it could be tricky when you plug it in. So you could just use synthetic division to evaluate. All right, next we have the factor theorem. So if a polynomial f of x is divided by x minus k, the remainder is r is equal to f of k. So if our remainder is 0, then this binomial is a factor. So if we get 0 as a remainder, then x minus k is a factor. So that's like what we did in the first example, because we got a remainder of 0, so that's why I said that x minus 2 was a factor. This is our factor theorem.
Is this where it has to go out evenly?
So it has to go in evenly because we want a remainder of 0. So in example 6, it says show that x minus 2 and x plus 3 are factors. So 2 different ways we can show that they're factors. We can use long division or you can use synthetic division. What do we want to do? Synthetic. What goes on the outside?
2.
Positive 2. So first I'm checking x minus 2. So positive 2 goes on the outside. What should go on the inside?
2, 7, -4, -27, 8, -18.
Awesome. All the coefficients. Always double check, make sure you're not missing any. I have x to the 4th, cubed, squared, 1, 0. Now, drop down the 2, multiply the outsides, add the insides, multiply, add, multiply, add, multiply, add. So I get a remainder of 0. 0 was our goal. Is x minus 2 a factor? Yes. So this is a factor. So I just divided out x minus 2. So now I'm left with 2. This would be x to what power? X to the 3rd power plus 11x squared plus 18x plus 9, and we have no remainder. So this can be my new polynomial, and now I can divide x plus 3 into this one, just to break it down more so I can find what all my factors are of this. So your goal is to break it down, like we divided, so now it's an x cubed. If I divide again, and let's say x plus 3 is a factor of it, then I'm going to have a quadratic here, and I know how to factor quadratics. So that's your goal, is to break it down as much as possible. So what goes on the outside? -3. I'm checking this one now, x plus 3, and seeing if it's a factor. But I'm using the answer that I just got here. It's easier to use the answer. Because our goal is to break it down as much as we can. So you just want to keep dividing to make it a smaller number, smaller binomial, or polynomial. What coefficients go in the box? 2, 11, 18, and 9. Drop down the 2, multiply, add, multiply, add, multiply, add. And we get 0 again. So is x plus 3 a factor?
Yes.
Yes. Now it says find the remaining factors. So I'm going to use these new coefficients and break that down into the factors. So 2, what would my
X squared
2x squared
plus 5x
plus 5x plus 3? So I'm going to rewrite it down here. 2x squared plus 5x plus 3.
In fact, 2x plus 1, oh no, plus 3 and then x plus 1.
So I'm going to multiply the first and the last. I get 6. What are 2 factors of 6 that add to 5? 3 and 2. 1 and 6 wouldn't work because neither one is negative. So x plus 2, x plus 3. What do I have to do next? Divide by 2. Since I started by multiplying by that 2, I have to divide by 2. It simplifies to x plus 1. This one doesn't simplify, so I move the 2 to the front. 2x plus 3. So these are 2 more factors in addition to the 2 that I found in the beginning, or that I double checked in the beginning. So x minus 2 and x plus 3. That came from here. So these are my factors.
You don't want us to write like x equals 1 and then like.
So on the next slide, this is kind of just a summary of everything we just did. You too. The remainder gives you the value of f at x is equal to k. So the remainder gives you the value. So this is when it says evaluate. This one is like example 5 that we did. So we can use our remainder to evaluate. If our remainder is 0, then whatever we divided into it is a factor of our polynomial. This is like example 6. And then if something is a factor, we can just take the 0 of that, so solve for x, one of our zeros, and that would be our x-intercept of our graph. So if something's a factor, it's our x-intercept.